Welcome to another class with Mathemasoft. In this video, we will start discussing highest common factor, and sometimes you can also see this being replaced by greatest. So either you call it highest, either you call it greatest common factor, either you call it biggest common factor. Okay, biggest. Okay, whether you call it biggest common factors, so they all mean the same. So in the last video, we've actually concluded on LCM, lowest common multiple, and this is highest common factor, and we are still using the knowledge of our prime number that we have been treating for a while now. So we are still going to use that knowledge to understand what highest common factor is. So let me give you some background. Let's say we are being asked to find HCF of let's say 4 and 8. Okay, so that is, they want us to find highest common factor of 4 and 8. So we are using the word factor. So if we are to list out the factors of 4, we are going to say the factors of 4 are 1, 2, and 4 itself. And the factors of 8 will be 1, 2, 4, and 8 itself. So let's first write out the common factor. That is, what are the factors common to this 4 and this 8? So what are those factors? So if you check, you will see that 1 is common to both of them. So we are going to write 1. 2 is common to both of them. We are going to write 2. And the last one is that 4 is common to them. So we are going to write 4. So these are the common factors. Now, out of these common factors, which of them is the highest? That's what we mean by highest common factor. Out of these common factors of 4 and 8 we have written out, that would be a singular because that's just one. Out of these common factors of 4 and 8, which are the common factors are 1, 2, and 4. Out of them, which of them is the highest? So obviously we'll see that what 4 is actually what the highest common factor here. So we are going to say 4. Now we can say therefore HCF of 4 and 8 equals to this, which is what 4. So 4 is actually the highest common factor between 4 and 8. So that's the background. So it's just more or less like listing out the factors of the numbers being given one by one. Then we bring out their common factors that are common to them, just like these 4 and 8 here. The common factors to them are 1, 2, and 3, and 4 rather. So that's 3 common factors. So out of these common factors now, we can see that between among 1, 2, and 4, 4 is actually the highest, and that is why 4 emerged as the what HCF of 4 and 8. So that's the background. So the same two approaches we used while discussing LCM, those two approaches are still very much applicable to HCF. So the first one, I hope you could still remember, that's the one I call tabular, okay, method. Okay, so tabular method, and we are going to list some examples. Okay, let's say some examples. Find the HCF of, let's have like 2 questions. Let's say 8, 16, and 24. Let's say the second one is 9, 27, and 81. So we have to find the HCF of these 2 questions. So the first one, which is the tabular method, that's let's rule. So we have our table, and then we have 8, 16, and 24. So the same approach. What is the first prime number we can use to divide them? That is 2. That will give me 4, 8, 12. What's the next one? Is still 2, 2, 4, 6. Next one is still 1, 2, which will be 1, 2, and 3. Now, the only clause in HCF is that, unlike LCM, that you have to divide until you have 1, 1, 1. Unlike in the LCM where you have to divide until you have 1, 1, 1. In HCF, once you get to a level where you look at the numbers that emerge, like this one now, the number that we have remaining here is simply 1, 2, and 3. So any number you want to use to divide must be able to divide the 3 or the numbers that you have here. In as much it cannot divide one of them, then you cannot use it. If I want to, if this is LCM, of course I'm going to continue with 2. But in this case, if I should use 2, 2 cannot divide 1. 2 cannot 2 can divide just 2. It cannot divide 3. If it's in LCM, I will still do this irrespective. I would definitely use that 2 to divide the 2 and then bring down these 3. But in HCF, the number you want to use to divide must be common to these 3 numbers as an example in this case now. So because 2 can divide 2, but it cannot divide 3 and it cannot divide 1, and there is no other number I can choose now that can actually go in the 3 of them, then this will mark the end. I'm going to say stop. Why am I stopping here? Because there is no number again that can go in these 3 numbers. In HCF, you have to note that the number you will use must be such that can go in all these 3 numbers. So if there is one that you see that is an odd one out that maybe you can't divide with any prime number again, then you have to stop. So in this case, I have to stop. Once we solve the next example, that should actually get better. So you stop here and then you say HCF equals 2 times 2. That's the multiplication here times 2, and that will give us 8. So therefore, we say HCF of 8, 16, and 24 is actually what? 8. 8 is the highest common factor to them. If you want to list it out, definitely you will see that it's actually we actually correct. If you want to use my foundation that I used in explaining to you, if you are going to list out the factors of 8, now you say 1, 2, 4, and 8. List out the factors of 16. You say 1, 2, 4, 8, 16. List out the factors of 24. You will say 1, 2, 3, 4, 6, 8, 12, and 24. I guess all are actually present. Okay, 2, 3, 4, yes, 6, 8, 12, and 24. So let us see which one are the common factors here. The common factor, let me call that CF. The common factors here will be 1. 1 is common to them. 2 is common to them. When you look at it, 1 is common to them. 2 is common to them. Okay, 4 is common to them. So you write your 4. You see that 8 is the next thing that is actually common to them. So nothing is common again. So which one is the highest out of 1, 2, 4, 8? That's the HCF now. You see, of course, 8 is actually the highest. Okay, and you can see that we got the same thing. So I'm just actually trying to show you with the fundamental knowledge I first used, so that you can see that our tabular method is quite correct. So you just have to note the little difference between HCF and LCM. In LCM, you divide until you get 1 all throughout. But in HCF, once you get to the level where the number you want to use cannot divide at least even one of them, you have to stop. So let's try number 2. In number 2, I have 9, 27, and 81. So 9, 27, I have 81. So let's draw our table. So I can see that the first number I can use is actually 3. That's why I put 3 there. So 3, 9, 27. I can use 3 again. Okay, that's 1, 3, 9. Normally, what I would say I want to do again is for me to use 3 if it's actually what HCM. But when you look at this, yes, that 3 I want to use now can go in this 3, can go in this 9, but 3 cannot go in 1. Okay, and just like what I said in the when we are solving number 1, is that any number you will use to divide must be able to divide the 3 of them. Any number you want to use must be able to divide these available numbers here. If there is one of them at least that particular number cannot divide, then you have to stop. So there is no common number that can divide them again. Okay, because 3 can divide 3, can divide 9, but it can't go in 1. So I have to stop there, and then I will say HCF, okay, now equals the multiplication of this. That will be what? 3 times 3, and that will give us what? 9. So 9 is the HCF of 9, 27, and 81. If you really want to try this, you can use the fundamental proving that I actually showed you. You will see that if you list out their factors one by one, that's what you still have. But this actually make it what? Easier, because listing out their factors, you could actually make mistake, especially when you have a big number like 81. If there's a mistake along the line, maybe there is a particular factor that you miss out, that will lead to what? An error, and you may miss, your score for that. So that's why if you use this tabular method, it makes it what? Easier. Just take note of the difference between when you are using it for HCF and when you are using it for HCM. When you are using it for HCM, you divide all through until you get 111. And when you are using for HCF, once you get to the level that at least one of them cannot be divided by a particular prime number you want to use, then you have to what? Stop. So this mark the end of this video. In the next class, I'll be sharing with you how you can use product of prime factors to actually do this. That's the second method we use in LCM to actually solve this. And in that example, in that next video, I will try to retain these questions that we have so that we can still use it, because we already have their answers here, and we'll see if they will result to, if the second method will also result to the same answer. So you can try out this. Let me give you some questions. Okay, this is your practice. Find the HCF of 1. Let me give you 20, 30, okay, and 40. The second one, let me give you 21, okay, 42, all right, and 51. Okay, you can try this, find the HCF, and please put your answers for me in the comment section below so that I can actually see if you have a good understanding of this. See you in the next class. God bless you. Bye for now.